Hey there, this is 4.4. This is about enthalpy and stoichiometry. If you understand what stoichiometry is about already, you could possibly skip this unit altogether since it's basically only math. Otherwise, you can stick around and watch it, right? So we're going to work on two mathematical problems, two examples involving energy or enthalpy and stoichiometry. So let's start with number one. The air pollutant sulfur trioxide reacts with water in the atmosphere to produce sulfuric acid and heat. So we have the reaction over here, and we see that this reaction releases 129.6 kilojoules because it's on the product side. How much heat is released when 583 grams of SO3 react with water? So in this particular reaction, we have 1 mole of SO3 when it reacts with the proper amount of H2O, which is 1 mole, releases 1 mole of H2SO4 along with this amount of energy. So what I'm really interested in is this substance and the amount of energy involved in the reaction. So this chemical reaction equation tells me that for every mole of SO3 that reacts, 129 joules, or actually 129.6 kilojoules, sorry, of energy is released because it's on the product side. They're asking me how much energy will be released if 583 grams of SO3 reacts with the proper amount of water. So how many moles do I have here? I have 583 grams divided by its molar mass, which is 80.062 grams per mole. So let's put this in parentheses. So this represents my number of moles of SO3 that I have, which is really, by the way, just if I give you the equivalence, 7.2819 mole. Okay, so if I have this amount of moles, and I know that 1 mole of SO3 will release this amount of energy in this particular equation, they want to know how much energy will be released by this mass of SO3. So my X is equal to 943.73 kilojoules. Now, let's not forget this energy is released because it's on the product side. And let's look at the significant figures. This coefficient does not count. It's a coefficient, it's not a measurement. Here I have 3 significant figures. Here I have more than 3, and here I have more than 3. So my final answer should have 3 sig figs, which is minus 944 kilojoules. So that's example number 1. In this example, we have ethane, C2H6. It's one of the substances that make up natural gas. The question is asking, calculate the energy released by the combustion of ethane when 10 grams of water is produced. The molar heat of combustion of ethane is 1,428.5 kilojoule per mole. First thing I need to do here is write down the equation of the reaction. So I have C2H6. Now, since this is a combustion, I know that this should react with some oxygen. And I know that combustions release carbon dioxide as well as some water vapor. Second step, I need to balance this equation. So it gives me 2C2H6, 7O2, 6H2O, and it gives me 4 CO2. Now, since the question says that the molar heat of combustion of ethane is 1400, multiply this value, that means I'm going to produce double the amount of energy, or release double the amount of energy, which is 2857 kilojoules. Now, since it's a combustion, it's being released, so it's on the product side. Okay, so they want to know the energy released by the combustion if 10 grams of water is produced. So what am I comparing? I'm comparing water to energy. So the first thing I need to do is to convert that mass of water, 10 grams, so 10.0 gram, into a number of moles. So I get, for the molar mass, 18 grams per mole, which gives me a total amount of moles of 0.5556 mole. Now I'm comparing, in this particular reaction, for every 6 moles of water produced, 2,857 kilojoules of energy are released. So I'm going to do a ratio with that. So I say 6 moles of H2O, when they are produced, will release, or will be part of a reaction that releases 2,857 kilojoules of energy. Now in this case, I'm not working with 6 moles. I calculated that there's only 0.5556 mole produced. And I want to know, in this case, how much energy would be released. Well, the answer in this particular case is E for energy is equal to minus 265 kilojoules. Okay, so when 10 grams of water is produced, or in other words, 0.5556 mole of water is produced, by doing a ratio based on my reaction equation, I get that for this amount of moles, this amount of energy will be produced. So there you have it. Goodbye.